And welcome to the DMM video, where we're going to start talking about how to make some measurements here. And I've got my Mastech MS8264, which is the suggested DMM for the class. DMM stands for Digital Multimeter. And so what I've got here is an array of batteries. And so I'm going to kind of walk through some of the similar measurements you're going to make in Lab 1, but then also just to show you the functionality of the DMM, okay? So the first thing you'll notice here is that you've got a dial here. This dial is switching between not only the different functions, you know, like up here, if we turn on the dial, okay, all manually. So you can see here where voltage with the little, looks like a little sine wave next to it. This is all AC voltage, okay? And so most of the time in this class for voltage measurements, we're going to be right here where the voltage has the little straight line next to it, from 200 milli all the way over to 1,000 volts, okay? So this thing will do up to 1,000 volts maximum. Oh, there goes my batteries. It is a Cat 3, Category 3. So, you know, it does do some higher voltages, and it is fairly safe. I've never had it tested before, but it does have some safety mechanisms on the inside. And so if you want to make a voltage measurement, an AC voltage measurement, or if you want to make a DC voltage measurement, your leads have to be like this, okay? You can see here on this terminal, you've got the voltage, the ohms, and the hertz. And then also you can see there's a diode up there. So this is where you're also going to do your continuity checks, okay? And so if you want to make a voltage measurement, you have to have the red lead here. The black lead never changes. What changes is where you have this red lead, okay? So if you want to make a resistance measurement, that is done up here at the top. You can see that, right? A range of 200 and then all the way up to 200 meg. Okay, so very, very high resistance measurements. So everything that you have in your kit can be measured with that resistance range. And so what this means is, and I'll get more into this later on the resistance measurement, but each one of these ranges in a particular function means that if I'm set at 200K, all right, I can safely measure anything, and I can report anything from 0K all the way up through 200,000. If the measurement is higher than 200,000, which as you can see here, I've got my leads open, and so that's an infinite resistance. And so what you'll see on the screen when that happens is a 1, right, because it's overloaded. So the range there means that you can't go any higher than that. So the difference between having it here versus down here is if I'm measuring 100 ohms, I'm going to see a lot more digits of resolution in a smaller range, as opposed to, you know, if I just had 100 ohms here, it's going to be the point up on the screen, okay? So because it has to account for, you know, 197.2K or whatever. If I only have 100 ohms, then I only have this digit of resolution to help me. And I know that that's got a glare on it. I'll try to keep it to the side. So that digit over there on the right side of the decimal, that's the only thing that would measure hundreds of ohms here. Okay? So I want to be down here where all of this is devoted to, you know, up to 200 ohms. So I can get a lot more resolution that way. So you want to choose the lowest range without damaging the function. Okay? So anyway, so voltage, DC voltage, AC voltage, and we'll zoom back here on the dial, and we'll move this back just a touch. Okay, and so now down here on the bottom, I'm sort of skipping this HFE. That is if you wanted to measure the gain of a transistor, and I don't know if you can read that or not, the HFE right there. Okay, and so if I had a transistor, and if I had this thing plugged in, and so it goes like this. So you can see the pluses on the right. It would go in, whoa, oh, it would go in right here where you see the capacitor and you see the HFE here. This has to be plugged in, so I guess I lied that the COM never leaves that spot. If you want to use these other functions, then you have to plug in this thing. And now when you have this plugged in, this little attachment that they send with you, you can see here that between here and here you could measure capacitance if you were up here in the farads. That's what this F is. So these over here are to measure your capacitances, okay? And so you have to have this plug inserted to do that. And then it's the plus and the plus and the minus up here are the two terminals you would use. If you're looking at an HFE, so if you wanted to find the gain of a transistor, which we don't do in this class, then you would use the bottom terminals on this thing, okay? The other thing I'll show you real quick, since I do have it hooked up, is this thermocouple. And this is a type K thermocouple. And that's what this thing is accepting right here, okay? And so you can see that it's marked positive on one side. That's the side that you want to go in to this right here. And then if you have it turned to degree C, okay, which is turned to degree C up here, okay, so now it's measuring this as a thermocouple. A thermocouple is nothing more than two pieces of dissimilar wire that are wired together and then fused at the end, and then the other end is open, and it responds to temperature. So a temperature change will actually produce a millivolt response on the end of these terminals. And so what we can do is, as you can see here in my room, it is 22 degrees Celsius, and 72 degrees or 73 degrees is 23 degrees Celsius. Okay, so that is room temperature. So we're about at room temperature here. It's fluctuating between the two. Okay, but just wanted to show you that as well. So you do have a way to measure temperature, and we do not cover thermocouples in this class, but it came with the meter itself, and so I thought I would point that out. Okay. Now, if you have a continuity, that's this next one up here, next to the C. Let me get zoomed back in to the panel here. Okay. So you can see where my yellow dot is. It's on that thing that looks like a diode, right? Right here. And so here's the marking for the diode over here. And so if I wanted to measure continuity, or to check to see if a diode was still good, or if I wanted to check to see if a fuse was still good, okay? I can take my leads as they're plugged in as you see them, and I can take, like, here's a 10 amp fuse that comes out of a fluke. Okay, and let's see here. I think this one doesn't have the, let's see. This one's the continuity checker, sorry. The one next to it. So you can see, all I did is I'm putting the two leads on each side, and you can see up here where it says resistance, the very last terminal there, there's a little, I don't know if you can see it, but there's a little, it looks like an amplification of sound there. And so what it's doing is it's telling you you have an oral cue to see if a fuse is still good. So if you've got one in your car and you can't tell, if you hold it up to the light and you can't tell if your fuse is good, or if you have one in your house or whatever, you can always measure and see if there's continuity. So there's no measurement there. It's just checking to see if there's continuity from one end to the other, which if a fuse is blown, you will not hear that sound. Okay? What else? Okay, so I guess the last two things we need to talk about here are the 2 amp, because this is the thing that you really need to pay attention to when you are dealing with a multimeter, because this is the easiest way to damage it. So you can see here, it's the ammeter stuff is all in the same place. So down here, you've got the A with the, again, it's kind of like the V with the straight line. So that 200M and that 20M and that 10, the one on the bottom, closest to 6 o'clock, if you're looking at it like a clock. So this one, and this one, I guess I got these to point with. That range, that range, that range. These are all DC amps, okay? These over here, with the A with the little sine wave next to it, 2 milli, 200 milli, and 10 amp. Okay, now the 10 amp has its own socket over here. And so I can't think of any lab where we actually use this 10 amp socket. Everything we do is going to be in this. It won't be, well, I shouldn't say never, but I don't think it's going to be any higher than 200 milliamps if we have to actually measure it, okay? Because we're only dealing with a 9-volt battery for all the stuff that we do. So unless I just had really, really small resistors or something. So anyway, when you make an ammeter measurement, you have to move this over. And this will be covered more in depth when we talk about actually measuring amps. But if you wanted to use DC amps, either in the 20 milliamp or the 200 milliamp range, then you would use this terminal. If you want to do 10 amps for either function, then you have to bring this over to here. Okay? Now, you can see down here at the bottom that this one is unfused. So if you make a mistake on that one, you're going to blow up the meter, okay? Because that one's unfused. So now this one on the milliamp terminal to ground, this one is resettable, okay? Now you may have heard me talk about this in class. The resettable fuse, I don't know if you can get it to read. Yeah. So where it says resettable, what that means is it's kind of like a, I have one in here, a paper shredder. When you try to feed too many pieces of paper through it at once, and there's a thermal switch in there that gets too hot and shuts it down so that you don't burn up the motor. So I think there's something similar that goes on. Then it gets hot, it blows out the terminal, whatever is there, and then it seals itself back up, and then you can reuse it. So if you start measuring 0 milliamps on everything, it's possible that you blew the fuse. Now, somebody over the summer, I don't know what they did, but they managed to completely short the thing out, and they actually damaged their device. So I don't know what in the world they were doing. There's no way they could have just been using the equipment we were using. But anyway, so you have to switch it over to these terminals to use for current, okay? This one will do voltage and ohms and frequency, okay? All right. So now what I'm going to do is I'm going to go ahead and measure a couple of these batteries so you can see. Okay, I think that's going to be, I'm going to get over into, I'm going to use the 2-volt DC range because, except for the 9-volt, I'm going to move that one up. But these are all, all of these batteries except for the 9-volt. So the D and the C and the AA and the AAA. And I even have one of those little watch batteries, right here, if you can see that. So I'm going to measure each one and show you. To my knowledge, all of these, except for the 9-volt, all of these are brand new. I just got them out of the package, okay? So, again, I'm going to show that these all have the same voltage in terms of, I expect this to be as it says on the side here, which I don't know if you can see, it actually says on the side, whoops, this is hard to do in a mirror fashion here. I don't know if you can see it. It says 1.5 volt battery on the side of it. Okay? So, all right, so let me go ahead and measure the D. So I'm taking, anytime I make a voltage measurement, I don't have to worry about if a circuit is on or off or what's going on. I can make a voltage measurement anywhere. So I just put the black terminal on the bottom, on the negative side, and then I put the positive terminal on the side with the little nib. Okay, so there you go. A D battery is not just 1.5 volts when you buy it. It's really closer to like 1.62, which, I'm down in the 2-volt range, so I actually get a little bit better resolution, and I can see 1.617-ish. Okay? So that's my first battery. So it's actually, the percent error is higher than 1.5. So I actually will get a positive percent error, which is good when you buy a battery brand new. Okay, now same thing. I'm going to put my negative terminal on the bottom, and then my positive terminal on the nib. This one's about 1.63. Okay, so same thing, a little bit higher. How they try to say they pack as much energy as possible into it. That's the kind of stuff they play with, making it a little bit higher than 1.5 volts, and then changing how much can be stored. Okay, so there's the C battery. Now I'm going to do the A. And again, negative terminal on the flat side, positive terminal on the nib, and this one is 1.633 volts as well. Okay? And so you might ask yourself, well, what happens if you get it backwards? Well, if I put the negative probe on the nib and the positive term on the flat side, it just sees it as a negative voltage. Okay? But it still has the same voltage potential, which is 1.5 volts, the absolute value of it. And then here is a AAA battery. And this one is about 1.61. I'm telling you, these Harbor Freight, they do not come off of that 1.6. They are definitely the lowest charged of the batteries. But, you know, like if you have kids like me, then you don't really care because they're just going to let something sit and, you know, the battery's going to die anyway at some point. Now here's a watch battery, and I'm using the flat side. Well, they're both flat, aren't they? The one that's got like a little bit of a nib to it there, okay? You can see the flat side is the positive, and so that's where the red goes, and on the other side where there's a ridge, that's where the negative goes. And if I could get my grip back that I had. So there you go, right on the money, 1.5 volts. Okay, so that's the kind of stuff that you are going to be measuring in the first lab, and hopefully that introduces you to your DMM enough to where you can go ahead and get started on the first assignment. And yeah, thanks for watching.